And I think we're back. I think doing World Machine really bogs my machine down while streaming. And it makes it cancel the connection, so hopefully it's all good and working. Let me know if everything's okay. Almost there. Any second now. There we go. Cool. So I've got a really cool, nice high-res height map now. The terrain, obviously the detail is different because we did a different erosion method, but let's do the version 2 now. So this is high resolution. Okay. So let's import this in now. And what I might do is do it as another height map actor, so we can see the difference between the different resolutions. And they're going to look different, but you'll see what's going to happen with the size. So let's zoom right out to our 4K range. There we go. So let's create a new landscape actor. So let's go to manage, and I'm going to do a new landscape. There we go. So that's the old one we had in there before. Let's try. Where did that export to? World Machine Terrain, generic landscapes. Okay, we didn't actually write it, but there we go. So now we've got this version 2, so let's do that. Okay, so now you can see what's happened. It's recognized the resolution, and it's done its best to fit the data. So it knows that it can fit it one-to-one. And it's done that, but you can see because the vertices are still 1 meter per pixel, then, which is this thing, each vert is 1 unit apart and scaled up by 100, then it's padded it out to 4K. Whereas if we wanted to fit this within the same area, we now need to scale it down to 50. So that's how we get higher resolution landscapes, is changing our scale values so that they map down to more than however many pixels per meter for your height map. You kind of just have to do the divisions, and either using a calculator. Now the other thing that kind of throws a spanner in the works is that that this thing, we've said that it's 2K, but Unreal is creating 4033, so the position of this is going to be a little over 2K. So what we could do is work out the math for this to make it exactly 2K. I tend to not do that, so let's import this. So I'll create it. There we go. Let's hide the original one. Okay, so this is a cool high-res height map. And now if we get our bush, where's that bush? A myrtle bush. Let's go with that. Bring it up, snap it down. There we go. So now we can see we've got a nice higher res map. So the divisions now are every half a meter as opposed to every meter. So it helps things a bit smoother. And when you put a normal map on here, that helps remove a lot of the apparent faceting. Let's bring in a skylight so it makes it look a bit better. skylight. There you go. That's just going to fill in all the shadows. So let me try and think about the actual width. It doesn't really matter that much, but if you want to be pedantic, then you can. I've not actually done this before, so what we've got is, it should be pretty simple to work this out. So we got 4,033, and we're trying to fit that into 2K, so we want to do divide by 2,000. So let's do that. Let's do 4,033 divided by 2,000. We probably want to go the other way, so 2,000 divided by 4,033. It's going to be 0.4959, so let's multiply that by 100. There we go. So this is what our scale, X and Y scale, needs to be to get proper like 2K scaling. So the rule for this is going to be, it's probably not this, so it's 2,000, so it's your input, so desired K, which is kilometers, divided by resolution. Yeah, that's right. And that's going to equal your X on Y scale. Oh, and times by 100. Times by 100. Because we're scaling up to meters. So let's put 49.59 in there. Can I copy that? Does Microsoft's thing not have a copy? Well, it probably does. Let's see if that pastes in. Landscape. Let's paste that in. Whoa, what's happening? 49.5, there we go. And our Z scale is going to be, now it's going to be what it was. It should be. We didn't change that elevation. So our project world parameters, yeah, so that should be the same. Which was 208.33. Let's unlock that. Why is that not copying? Copy, paste. Give it a second because it has to go and scale all the components. There we go. So that's going to give us an exact one-to-one from World Machine, even taking into account the strange resolutions in X and Y. You could even go higher res than that. You could do an 8K map, and then what you do is you do your design. If you're trying to fit an 8-kilometer render resolution, so not even taking into account this whole thing. This is you defining your World Machine range, which is like your artistic range, and then your build range can even do, render high res. So we could even do, I'm not going to do it because it would take too long, but we could do an 8129 map. And then what we would do is we would calculate, so desired would be 2000, and we divide by 8129 times 100. So then what you do is get this to 2000 divided by 8129 times 100. And that's going to give you a scaling value of 24.6, whatever. And you paste that into there, and that will bring back your 8K map down back to 2K, and then you'll have a higher kind of pixels per meter, render ratio. And you're controlling your absolute size, and you're getting your height values exact from World Machine. So that's pretty much what I want to show everyone. The other thing is textures. So you kind of have to do your height map exporting and your textures exporting separately, because you want your textures to be a power of 2. So if I'm going to build a normal map for this, if I want to go to normal map maker, so I can just create one of these, and let me get my erosion, plug it into there, and I'm going to create a new output. So tools, output, this is going to be mesh output, bitmap output. So I want to export a bitmap. I can't remember if you can import 16 bits PNGs as a texture, but I'm going to try. So let's do that, specify output, and this is going to be called generic normal VO2. Let's try that, and we'll connect that there. And this is going to be, now there is something I think you have to do for Unreal here. I can't remember which one it is, but you can always change it in Unreal as well. So let's write output to disk. Again, we have to build, but that was not much. Just we have to only build that one, then write it. So that's just writing it to disk. But the problem is that it basically does it at the resolution specified in the build resolution. So what we have to do is we have to go through and change this to a power of 2. You don't have to, but if you want mip mapping, you're going to want this to be, power of 2. So let me just go right up to disk, I press to build everything again. So yeah, let's go